Hello everyone. In this lesson, we will go through the code implementation of the A3 system that we discussed in the last video. And we will go into some details about the tags generator and the references generator because these nodes are relatively different from other nodes that we implemented before. And we'll also show the idea of encapsulation, meaning that you can use a graph inside another graph. So yeah, let's see. So I've prepared a script that contains all of the nodes that are used in this project. And we will go through the tags extractor and the references generator only because these are the only two different nodes. But feel free to check out the others. I'm going to go through a quick example of the manager node. So it's a very simple node. You define an LLM, you give it a prompt, and you just invoke it. So there is nothing special here. Similarly about all the other nodes. And yeah, if you want to check the prompt that was given to the manager, so you can go to the prompt configuration file here, and you pick the manager analysis, and yeah, you can see the prompt given to the manager. So I'm not going to go through all the nodes. So yeah, you can check it out. Now I want to go through the tag extractor node first. And if you look inside here, you can see there is nothing special. It's just that we're calling a run entity extraction function. So the new thing about this is this method is actually coming from lesson 2, the previous lesson. And if you look at what this is doing, it's actually another graph that we discussed in lesson 2. So we're talking about this graph, the graph that extracts entities from text using 3 different methods. So this itself is a graph, and if you look at what we're working with right now, this means that this node is an actual graph. So this is what we mean by encapsulation. So you have created a tool at some point, and this tool is itself a graph, but you can reuse it in other nodes, and this way we say we are encapsulating the tags generator inside of this node. So yeah, that's what I wanted to show about this node, is that you can keep reusing things that you built in the past, even if they are themselves are graphs, right? So yeah, this is the first thing that I wanted to share with you. So the second thing is the references generator. And I want to show you this node because it contains tools, it uses tools. So it is actually using 2 different tools. The first one is Tably search to search the internet for references, and the other one is called, I think it was called Selenium. Yeah, Selenium URL loader, which takes in a URL and then it gets the content of the web page, and yeah, we give it to the LLM. So if you look at this node, yeah, we are instantiating an LLM, we give it a prompt, and then I wanted to share this logic here because it's a custom defined logic of using tools. So the way we used tools before is that we gave the tools to the LLM, and we called a function on the LLM object that was called .bind tools. So yeah, you can give some tools to the LLM, and then the LLM is then it can decide to use these tools whenever it wants. But this time it's different. We're not giving the LLM the choice to use these tools whenever it wants, because we know exactly when we want to call these tools. So we know that whenever this node is running, it will need to do some web search, and it will need to get the content of some page. So we don't give the tools to the LLM. Instead, we directly call the tools inside of this node. So whenever this node is running, the objective of the LLM is just to give you some search queries. So for example, let's say, again, I'm using the same example from the last video. We're writing a publication about transformers. Now the job of this LLM is to give you some search queries to use to search the internet, such as transformers, LLMs, attention mechanism, whatever, some queries related to the topic. And then we will use these queries to perform a web search. And then this web search will give you some URLs. We take these URLs and we give it to the other tool to load these pages. And now that we have this content, we give it to another LLM to pick the references for us. So yeah, that's it about this node. I just wanted to share the idea that you can have tools and you can call them directly inside of your node. You don't have to give them to the LLM to decide if you know exactly when to call these tools. So like any LangGraph project that we work on, we have to define a state for this graph. And the state is a little bit more complex than the previous ones. And this is because we have more agents and we wanted to do some coordination between them in some way. So yeah, to give you a refresh, this is the graph that we are working with. We have a manager node that should give general instruction to all of these nodes, and they should follow these instructions. And all the results from these nodes go to the reviewer. And then the reviewer reviews the output from each one of these, and it can choose to go back to one or more of these nodes for the agent to refine its output, and then the review happens again. So in order to implement this, we will use this state, right? So the text attribute is the main input of the user. So the user might say, I want to write something about transformers. I want to write a publication about whatever, my project. And it can contain whatever information you want here. And we have these 4 attributes. These are the final outputs of the system. So after running the system, you can get your output from these attributes. And then we have what we call the manager decision. So it's going to be the general instructions that the manager gave that these nodes should follow. We have what we call revision round. So we are putting a restriction on the number of iterations you can do in revision, because it could happen that this system might make a lot of loops in the revision part. So we don't want that. We want to limit, for example, the number of revision rounds to 3. So do not do revision more than 3 times. So that's why we are having the revision round here. And we are having what we called a needs revision variable. So this is a boolean, it's either true or false. It is set to, if it is set to false, meaning we don't need revision, so the reviewer goes to the end state, means we're done. And if it's true, it means that one or more of these agents need to refine its output. After this, we have 3 different feedbacks, one for the TLDR, one for title, and one for references. And what this means is whether each of these agents need feedback or not. So, it's the actual feedback given from the reviewer to one of these nodes. So, for example, the reviewer might not like the title, and it should say why does it not like the title. So, for example, it might be that the title is too short, or the title has nothing to do with the main theme of the publication. So this information, that the title is too short, would be written in the title feedback, and it would be given to this agent. Similarly for the TLDR and the references. We don't have a variable for the tags node here, because the tags node is actually deterministic. It's not using an LLM, or it is using an LLM, but it's an encapsulated system, and we don't give it a prompt. So from the point of view of this project, we don't have access on the things that are going inside here. So it's as if it's not using an LLM. So how am I supposed to give it feedback, right? There is no way to give the feedback to this node. We could implement it in a way to allow this, but I wanted to show you that sometimes you can have deterministic systems, and these systems, you won't be able to give them feedback. And finally, we have 3 different attributes for approval. So again, it's Boolean, so true or false. And it means, did the reviewer approve the TLDR or not? Did it approve the title, and did it approve the references? So if all of them are true, it means that needs revision is going to be false, because you approved everything, then you don't need to do any revision. Okay, so now we've discussed some of the nodes, and we discussed the state that we used. I'm not going to go through the code for creating the graph because we've done this more than one time by now, and there is nothing new there. However, if you think that there is anything confusing, feel free to leave a comment on the publication, and yeah, I can always update the content or answer your questions. So before ending this video, I wanted to talk a little bit about memory or context sharing in such systems. So right now we are using LangGraph, and the way that LangGraph works is by providing a state. And this state, it's literally given to all of the agents, right? So whenever a node run, so if you look at the nodes that we have here, all of them take the state as an input, which means that all of these agents have access to all of the attributes inside of the state. And this approach has pros and cons. The good thing about this approach is that it enables sharing context easily between all of the agents. So for example, when we talked about the manager node gives instructions, and these instructions are stored into the state. So whenever any of the other nodes runs, they can access the instructions given by the manager. And this is a good thing about this approach. It's very, very easy to share context between one agent and the other. However, there is one downside to this, which is, you might actually say the exact good thing about this approach is the bad thing, which is all of the agents, again, have access to everything. So for example, the TLDR agent, it has access to the title. It has access to the tags, which might be good in some implementations. You can give it to the agent to let it know what the other agents have done. But sometimes, yeah, you're giving more information than you should give. So some agents might have access to things that they won't do anything with, right? And yeah, this is a very unnecessary transmission of information between agents. And in this project, it's not that bad. But I have worked on projects where I had agents more than this. And yeah, it's a little bit hard to handle the state and handle transmitting all of these information to